Entra ID, the application formerly known as Azure AD? Do you leverage it fully? Are you aware of all the features and everything that comes with it and how you can best secure yourself with it? Well, if the answer is no, today we're going to fix that because we're doing an Entra deep dive. But first, my name is Mark Connolly, and I'm a cloud security architect here in the greater Chicago area. I work for Empyreon, and we help small businesses with their Microsoft 365, IT, and cybersecurity needs. Now, we have historically seen a lot of customers make this one mistake, and that is not leveraging their Entra ID or Azure AD properly. The name changed recently, so it's going to take a little while to get used to that. But most notably, the area of troubleshooting sign-ins, like you set a system up, somebody puts in a ticket and you don't really know how to go through stuff and figure out what's going on. In today's world, identity is just absolutely critical. Having an identity provider that you can leverage to give single sign-on services to your organization is a really important step in your identity and access management journey. And most of the time, you're already paying for it. You just don't have it leveraged properly. To add to the confusion of all of this stuff, Microsoft rebranded to Entra ID from Azure AD. That is going to cause a ton of confusion. But they added a few extra products to Entra under the Entra umbrella. So by the end of this, you should have a good understanding of the Entra Identity platform, be able to troubleshoot sign-ins, understand the application of security attributes and conditional access policies. So I've been using the Entra portal for a long time now, and I'm actually a fan of it. I've always found it a little bit easier to navigate and manage identity-related tasks, and I'm pretty analytically minded to begin with, so logs in general are highly valuable to me. So if we identify the problem, in our example scenario, your company recently implemented conditional access policies, or maybe you recently migrated to the cloud and are just getting started with the ideas of users signing in against the cloud. There's always going to be a few issues, and users are going to submit tickets. Your support staff are going to have to troubleshoot on a completely new platform. And that will represent its own set of operational challenges. So does that scenario sound familiar? It happens all the time when you migrate to new technology. That learning curve of getting to the new technology is always painful. So the help desk is generally going to take the initial calls in these cases, but particular issues may get escalated up the chain and end up on an engineer's desk. So no matter what your rank, we all need to be confident in our ability to quickly find and analyze the log information and troubleshoot any particular issue. So let's get started with architecture, because before we can really dig into the logs, we need to understand the system that is producing those logs. And I'm not going to go into exhaustive detail about the inner workings of Entra, but let's take a minute to do a high-level overview. If you want to catch up on some of my best practices, you can check out the videos here in this playlist. So Entra ID, formerly known as Azure AD, is our cloud identity provider. We may or may not sync users from on-premise Active Directory. We may or may not sync devices from on-premise Active Directory, but regardless of how those users and devices get there, we use Entra ID as our identity provider, allowing us to be our own single sign-on provider. It natively supports modern authentication. It's cloud ready for all the new software, services, and cloud things that are popping up everywhere. And then as the identity provider, it's also aware of relevant information related to your users, devices, and applications. So we're going to be discussing topics that I've covered in those previous videos, so I highly recommend that you take some time and get yourself familiar with custom security attributes and as well as conditional access, because those are cornerstone technologies in the Entra platform. And as more and more workloads get migrated to the cloud, the corporate network becomes less and less important. Applications natively can be accessed from any location on any device because it's on the public internet. When you're in cybersecurity, though, you realize that is a horrible, horrible, horrible idea. Those sign-ins definitely need some kind of control, and we need a cloud firewall for these types of sign-ins. And luckily for us, we have just that. So on the Entra platform, conditional access is our cloud firewall for identity. It allows us to collect a crazy amount of signals during the sign-in process, and we can set policies to control that sign-in. So we can decide whether it should be allowed, and if it is, what kind of other conditions have to be met. The sign-ins must meet the requirements or they will get rejected. All right, so let's start with understanding users, devices, and applications. So now that we know the problem and we know the architecture of the system, next we need to take a look at the various pieces of the puzzle. So to do that, let's switch over to the Entra portal. So if we navigate over here on the left-hand side to the identity section, we can navigate to our users and check into the user object specifically. From here, we can pivot to user details, group memberships, and other things. We can do the same thing with devices, but generally you're going to handle the management of devices in another portal. There's endpoint.microsoft.com that's built for that, but it is a part of the directory, so you will be able to see it in Entra as well. So this means that we can see most of the relevant device information that we need to troubleshoot inside of the Entra portal. So, endpoint.microsoft.com, the desktop guys, the PC guys, they're going to create all their configuration profiles. That's going to be their main portal. Entra, the directory, as an identity engineer, is going to be your main portal, and that information is shared between those two. So the last thing that we have is applications. So whether you create the app yourself or you use a pre-made app, each application is going to get a service principal inside of your directory. This service principal is where the SSO configurations are made. And whether you use SAML or OAuth, you can update this object to set that up. So the next big thing that we have is custom security attributes. And this is a big piece of the firewall puzzle in our conditional access policies. And it's relatively new. So it's a preview feature. Not a whole lot of people are aware of this, but it's incredibly powerful if you use it properly. So we do our best here to design modular policies that can suit our clients' needs, right? And the easiest way to scale that is by combining role-based access control with attribute-based access control. If we take a minute and jump back to that diagram, you'll see that down at the bottom of that diagram, it said RBAC plus ABAC. And that is the marrying of role-based access control and attribute-based access control. Custom security attributes are currently only supported on users and applications, so I hope that they will get support on devices soon, but in the meantime, we have extension attributes on devices that we can use in their place. But for all intents and purposes, I'm just going to call all the attributes custom security attributes, including for devices. So if we go over to the left side of the menu, under the protection menu, we can navigate down and see what our attribute sets are. For general use, we have attributes that apply to users and applications, things like which department owns them and which cost center they fall under. For users and applications specifically, for the things that are only for those object types, we want to set other types of attributes that apply to them independently. So for applications specifically, we do set attributes that coincide with our conditional access policies. And this allows us to keep a baseline security level as well as have the option to ramp up security for specific applications as needed. So while we can, Dropbox comes on, it's going to fall to the global default. But if you onboard maybe a legal software that has sensitive information about your clients, you may want the security for that application to be a little bit higher than the global default. And for that, we're going to use the custom security attributes. Flip the switch, conditional access will take over, and it'll have higher level of security. So in this attribute set, we have things like always require MFA, use GPS location, requiring an admin access workstation, and much, much more. Once you define a policy set that is right for your business, combining this feature with the one we're going to talk about next is really, really powerful. We just need to navigate over to the application we want, go to the specific attribute, set them, and the security policies are just automatically going to pick them up. All right, so now that we've covered security attributes, the next thing that we're going to go over is the actual conditional access policies. So under that same protection menu is conditional access over here on the left. And in here, we define a few objects that we need to use in our policies. So this is an important thing to keep in mind. The named locations is where we create network and country-based objects that we're going to use in our policies. So this would also be the place to create any terms of use documents that you want, or any terms of service, maybe BYOD or other documents that you want your users to accept. You would create those here as well. So these are going to be a little bit different in every environment, and usually they're not ideal. You might inherit a policy set, and it's kind of messy. So I'm going to show you kind of an ideal version, and you can figure out how to go from point A to point B and incorporate those things into your conditional access policies. So this might look a little bit cleaner than what you're used to, but just keep in mind that this is an example, but it is really, really, really important for you to understand the policies that are enabled in your environment. And it's also very critical to looking at the logs. So, knowing which policies apply which control sets. When you're troubleshooting the sign-ins, we'll get to that in a few minutes, you're going to want to see that and be aware of which policies are applying which controls. Like I said, you can always take my examples and tweak them to your company's needs and improve your security posture as you see fit. So in our specific example, we have very modular policies. For the most part, each policy does an individual control or as few controls as possible. This allows us to apply a single or minimal set of security controls precisely, and it allows us to make granular exceptions as needed. So let's take a minute to review what we have in our example. So from the top, prerequisites, we need our custom security attributes defined. We need a named location for sanctioned countries. define that for via IP and GPS. We're going to set a name location for blocked IPs. We're going to set a name location for trusted IPs. And then we're also going to create a new authentication method for Authenticator MFA, which will set the minimum MFA check to the Authenticator application. So let's start off here at the top with our block policies, because the thing that trumps anything in conditional access is a block policy. So we put those at the top, and when you put your identity provider in the cloud, it's essentially open to the entire internet. So the goal of these block policies is to minimize the attack surface as much as possible, and we're going to just get started by just cutting off all the crap from the top. So first one, block unknown platforms. So we will set the exclusions on this, and whether it's Android, iOS, macOS, Linux, you put the types of platforms that you want to connect in here, and everything else gets blocked. The next big one is legacy authentication. We do not need legacy authentication. We don't need IMAP. We don't need POP. We just want to block that out of the gate. Everything ideally should be using modern authentication. So then the third one is to block unsanctioned countries via IP. So the outcome of this is that sign-ins from countries that are not explicitly whitelisted in that sanctioned countries object, they will get blocked. The next one is the same thing, except that is going to be leveraging the GPS attribute and our ABAC controls. So sign-ins to apps with this attribute from countries not explicitly whitelisted will get blocked. And sign-ins that do work will be GPS enforced. So the Authenticator app is going to actually use GPS tracking to make sure that you're in the country that is whitelisted. The fifth one, we've got block defined IPs. If you've got a firewall, you're used to the idea of bad guys hitting you pretty hard, and we're going to go ahead and just block those outright. So if we have a list of IPs that we know we don't want connecting to our network, we're going to put those in that object. The next big one, and this is a P2 feature, is to block high-risk users. So the outcome of this is that sign-ins from users in a high-risk state, they're going to get blocked. All right, so number 7 is block guest access for specific applications. So this is leveraging ABAC as well. So sign-ins from guests to apps with this attribute set will get blocked. The next one is to block shared access workstations for specific applications. If you've got a fleet of workstations at your company, and those are generally shared between people, there's a lot of applications that those workstations should never access, right? If you're accessing something of criticality or sensitivity, you probably don't want people from a shared access workstation connecting to it. So that's what this policy is for. Those machines will get blocked if that attribute is set. So that is it for our block policies. So off the top, we just cut a lot of traffic out that we don't care about. Then next, we're going to move into our global policies. So number 9 is to require MFA for Microsoft admin portals. So if you have an administrative role, whether it's Azure AD, Entra ID, or Azure Resource, and you are going to the Microsoft admin applications, it is going to prompt you for MFA all the time. And then you also want to set the session timeout, because that is a Microsoft specific app, and it doesn't have an attribute that we can set. So number 10 is, it goes in tandem with the block high-risk users. Another P2 feature, sign-ins can be classified as low, medium, or high risk. And based on the amount of sign-ins that are risky, you will elevate your user state up to medium and high. If you do successfully complete the MFA, though, it reduces your risks back to 0. Effectively. So the idea of this policy is that if you do something, if there's some weird sign-ins or some risky behavior, we're going to prompt you for MFA. If you confirm, that will drop your risk level back down. If you do not confirm and a bunch of other risky sign-in things happen, your user risk will eventually get elevated to high, in which case that block policy will catch you. Number 12 is that we are going to require MFA for browsers off network. So this is kind of a trusted locations policy. So we don't want to prompt people for MFA if they're inside the corporate office, but if they are outside the corporate office and using a browser, we're going to prompt them for MFA. We're going to do the same thing for desktop OSs as well. So sign-ins from applications on Windows, Mac OS, and Linux devices, if they're not from a trusted IP location, they're always going to require MFA. And then number 14 is to always require compliance for mobile devices and apps. On this one, sign-ins from applications on Android and iOS devices that are using a native application, they have to have a compliant device, they have to be Azure AD joined, and they have to report back that they checked all the boxes of everything that they need. Otherwise, they won't be granted access. So it's important to note between 12, 13, and 14 is that we're splitting out browser. The browser goes for all platforms, so whether it's a desktop or mobile. So if you're using a browser, you'll get prompted for MFA. If you're using a native application, there's a separation between the desktop OSs and the mobile OSs because we're applying a different control. So if you're using a desktop application like Outlook or Teams and you're off network, you're going to have to MFA. But if you're on a compliant device, mobile devices, this is more of a convenience feature. The MFA is replaced by the fact that your device is compliant. So that equates to MFA off network. So even if you are on a corporate Wi-Fi and you drop off, as long as your device is compliant, you will not then be prompted for MFA. So 15, 16, and 17 are similar to that. We're splitting out browser, and then we're splitting out desktop application, and then mobile application. So we're going to set the session timeouts in a little bit of a staggered stance. So browsers are going to get 12 hours, desktop applications are going to get 1 day, and then mobile applications are actually going to get 7 days. And then number 18 is to require an application usage policy acceptance. So this goes back to the terms of use. In this example, I have a policy that says these are the controls that are applied against these sign-ins, and you have to accept it before you can sign in for the first time. Then number 19, we're splitting out to the Microsoft 365 apps specifically. So we've got our global tier. We've got our blocks. That's stuff that is going to go across the organization. Any new app that you introduce to the environment is automatically going to inherit all of those controls. For Microsoft 365 specifically, though, we get additional controls that we can apply to only those applications. Again, we need to split out browser, desktop application, mobile application layers. So number 19 is the browser. We're going to require overall compliance. So this is sign-ins to Microsoft 365 apps in a browser that are not from a trusted location or other criteria that you dictate is going to always require MFA. Number 20 is for the workstation applications, we're going to require overall compliance. So we can require that they are Azure AD joined and that they are compliant. And then on number 21, we get a few extra bells and whistles. So for mobile applications, we're going to require overall compliance. But effectively, the outcome of this is that sign-ins to Microsoft 365 apps for mobile devices, they must be Azure AD joined, they must be compliant, they must also use an approved application. So like email, you have to use Outlook. And then they also have to have an app protection policy. So for Microsoft 365 specifically, I said on that app by app basis, we can increase security. This is what we're layering in on top of this with Microsoft 365 apps. So then to number 23, this is where we get into the security attributes. So security attributes can be applied to any application, Salesforce, Dropbox, whatever it is that you put into your environment, you can put an attribute on those. And the control that matches the attribute that you set is going to be caught by these policies right here. So number 23 is to always require MFA for specific applications. So there's some applications where even if they're on a trusted network, I still want them to MFA. If it is like a high criticality service, Hyper-V type situations, maybe VMware, if you have another hypervisor platform, maybe your firewall systems. If you've got, the Fortinet ecosystem, you've got a security fabric, right? Somebody logs into that, they have visibility across your entire system. I don't really care whether they're at the office. They need to MFA, right? And they probably should have an admin access workstation, and they probably should have other elevations of security as well. So that's just one, they're modular, so we need to set multiple attributes to get that collection of controls. But number 23 is to always require MFA. Number 24 is to require the authenticator MFA. So this is where we start getting into authentication strengths. So there's 4 levels in this example. The default MFA, which is Microsoft will let you text yourself or call yourself or whatever. Those are very insecure, but that is the default MFA. So the authenticator MFA is just removing all those low security features to where the minimum is the authenticator app. You can still do certificate-based auth. You can still do Windows Hello for Business. You can still do some of the other stuff. But the minimum is the authenticator app. And then on 25 is where we set the authentication strength to passwordless. So if we want to have passwordless logins for a specific application, we can set that attribute. Number 26 is phishing resistant MFA. So this is going to be a big one years down the road. But phishing resistant MFA doesn't actually require a password. It uses certificates, it uses Windows Hello for Business, FIDO2 keys, other things that are phishing resistant because you can't easily duplicate them or trick somebody into giving them to you. If your device has a certificate, you need to come from that device in order to pass phishing resistant MFA. So if a hacker is trying to steal your password, you can't give that hacker the certificate from your computer. So they just won't be able to sign in. So I'm really, really excited about that one. I like it so far in all my testing. So number 27, we're going to move down to require Azure AD join devices for specific applications. So this just means that they need to be joined to the network. Azure needs to be aware of them, but they don't necessarily need to be compliant. 28 is going to be setting that security attribute that requires them to be a compliant device as well. Number 29 is secure access workstation. So the idea of what a secure access workstation is it is a device that was issued by your company that has all of your security baselines, AV, XDR, VPN clients, whatever protections you have in place at your company. When you issue a computer to a new user, that is a secure access workstation. So the security attribute to require a secure access workstation means you're not able to access that application from anything other than a company managed and compliant device. Same thing for number 30, except we're going to take it one tier higher. So a secure access workstation for an administrator. So if you have somebody who's a domain admin or somebody who's an exchange admin, you should flag the machine that they use as an admin access workstation. Because for administrative portals down the road, what we want to do is set this attribute so that we block everybody else other than the administrators on the dedicated workstations from being able to access that application. And then 31, 32, 33, we're getting down in here into session timeouts. So we have the global session timeouts, but on a app by app basis, we want to also be able to drop that. If we want something to be able to sign in, if we want them to sign in every day, then the global is 7 days. So we need to drop that down a little bit. We also have it tiered between browsers, desktop applications, and mobile applications. So these first few, the 5 day, the 3 day, the 1 day, those really only apply to mobile applications because they supersede the global. But then when you get down here to 34, we look at session timeout, 12 hours. That makes, if you set that on an application, that will mean whether it's browser, desktop, or mobile, it's going to have a 12-hour timeout across the board. And then additionally, 35, we can drop it down to 6 hours, and that is going to require somebody to authenticate twice a day during their workday. So these are the custom security attributes. I know that that's a lot to digest in a short period of time, but if you take a step back and kind of detach yourself from that, you think about it, we have 35 conditional access policies instead of 200. We're not creating conditional access policies on a per app basis. We've built a classification system for our applications and devices, and it allows us to break up our security controls very granularly and automate their application via our onboarding processes. So this allows us to have high security standards for things like the Microsoft admin portals or something like Splunk, and we can allow normal applications like Dropbox to just get a seamless sign-on experience because you've already got a token from most of your day-to-day apps that have higher security standards. To classify the devices, I use PowerShell to set the extension attribute 1. The values are shared access workstation, secure access workstation, and an admin access workstation. Classifying a device as shared access will block it from signing into many apps. Likewise, for zero trust models, only devices that are officially distributed and branded as secure access workstations can access certain applications. So you're going to need to establish operational procedures to make sure that devices and application attributes get set correctly and consistently. But once you kind of work out those kinks, zero trust takes a big step forward, right? All right, so user, application, attributes, and sign-in information. We need all those things to be able to troubleshoot. So if you're going to be troubleshooting Entra ID sign-ins, you need to gather information first. You want to know who that user is, what application they're trying to sign into, what device they're on, what their experience is, and what the expected experience is, because that's the only reason they put in a ticket. They expect something different than what they got. But a lot of times, the expected experience is exactly what we as security engineers dictate. So, if you're coming from a bad country, or if you're coming from India, for instance, and maybe you're supposed to VPN to the corporate network, before you sign into Azure, right? But you're like, hey, it's in the cloud. I don't necessarily need a VPN in the corporate network. So then you sign in straight to the cloud. You get blocked because your sign-in's coming from India. And you're like, oh, I should be able to log in. Well, no, you shouldn't. What I need to do is correct the user behavior and get them to sign in the right way. Likewise, maybe they're trying to access an application and it requires an admin access workstation, but they were never issued one. Well, the policy is that for this application, we require an admin access workstation. So to fix the problem is not to make an exception to the policy. To fix the problem is to get the user the proper workstation to be able to access that, right? So the expected experience is absolutely critical when you're getting information from the end user. So from there, we can actually do something. So for our use case, we're going to pick on our good buddy, Wade Wilson. Wade was trying to sign into the VPN. For example's sake, I switched the attributes up on the application and signed in multiple times to produce logs so that we could review them. But that wouldn't be the case in your example. So Wade has come from multiple devices and experienced multiple errors because he was trying to sign in any way that he could. For me, troubleshooting sign-ins, I like to pivot off of the user information most frequently. If you're in an MSP environment or enterprise environment, you'll generally have some sort of ticketing system, and user information can be required upon ticket creation, so you get that to start off with. But a lot of times, this is really the only valuable information that you start off with, and we kind of have to dig from there. So reach out to the user. I'm going to ask them a bunch of questions. What time did you sign in? What device were you on? Did you try multiple devices? What browser were you using? Were you on the VPN? Were you at home? Yada, yada, yada. Were you using a browser? Were you using a desktop app? Try and collect all of that information, right? Because then we're going to go look at the logs and we're going to see whether what they said was true and try and isolate the log that'll show us exactly what was blocking them or causing MFA or requiring a particular type of workstation that they may or may not have. So to get there, we're going to go to Entra portal and we're going to go to identity, users, and then we're going to click all users. So you can filter your list as needed and select your user object. From your user object, you're going to want to click sign-ins from the left-hand menu. Now, I like to collapse my menus down so I can see more of the log info, but that's my personal preference. So looking at the first login, we can see several factors that failed. So if you click into this, you can see the exact criteria that's getting caught in the sign-in. You can see location, you can see device info, you can see browser info, you can see the conditional access policies and whether they were applied or not. And if you have some policies in report-only mode, you can click the report-only mode option and see those as well. So on this particular sign-in that failed, we can see that the user and application matched. If there's items that failed, you'll see it marked with a red X. So in our example, Wade Wilson, we are coming from an in-private browser. From that, Azure can't tell if the device is compliant or not. So this app was set up to require a secure access workstation, and I was not coming in from one. So I got this error. So then I updated it and to not require that, but it was still requiring device compliance. So I was coming from an in-private browser. It asked me to switch to my work profile, which you can see in this screenshot right here. So I wasn't able to do either of those things because it was an in-private browser, so that sign-in failed. So I removed the attribute that required device compliance and Azure AD join since I don't have one that meets that requirement just yet. And then I was able to successfully log in here. And so in that successful sign-in log, if we go over to the conditional access, we can see that they're all green and that everything checked off. Require MFA, all the different controls, and then I was able to actually sign into the VPN application successfully. Depending on what you're doing, you may also want to pivot through the application. If you've got multiple users that are having sign-in problems and you're not really sure how to isolate it, if you go through the application, you can click sign-in logs, and that will filter the sign-in logs specifically to that app. So no matter who the user is or what they were doing, you'll be able to see the logs specific to that app and troubleshoot and pivot from there. So that is an overview of the Entra Identity platform and how we use it as our single sign-on provider. We have Azure AD Premium P2. We're able to implement all of the various custom security attributes that we need for our organization, tie those into our conditional access policies so that we can have a scalable infrastructure in 35 policies. So I hope this has been informative for you, and I hope that you can wrap your head around Entra, navigate the portal, and be able to troubleshoot sign-ins a little bit more effectively after watching this video. And if you like this stuff, go ahead and click subscribe and turn on notifications, because I drop new videos about cloud security, AI security, and a lot of various other things on a regular basis. Catch you in the next video.